more of section 2.3. Section 2.3, the rest of it is we got to be able to take care of the rest of these trig derivatives. So some crazy stuff here. We can handle derivative of sine and cosine. That's really not a big deal. Derivatives of the rest of these there's some patterns here, but you're not necessarily going to see them right away. So derivative of tangent is secant squared of x. Derivative of tangent of x, secant squared of x. Derivative of cotangent is negative cosecant squared of x. So you got a little bit of a connection there. Tangents and secants always kind of go together. Cotangents and cosecants always kind of go together. And then when we get over here to derivative of secant, cosecant, these are a little more complex. Derivative of secant of x is secant of x times tangent of x. And derivative of cosecant x, okay, so let's try to put a little pattern together here. What's going to go on with cosecant of x? Well, cosecant of x, cotangent of x, with a negative on it. So what's our pattern? Tangents always go with secants, and vice versa. Cotangents always go with cosecants. And then as far as patterns, tangents and tangent, cotangent always have the ones being squared. Secants and cosecants always have themselves involved, which is kind of odd. And then the ones that change, cosine, cotangent, cosecant, anything that starts with a C is going to change signs in their derivative. So anything that starts with a C is going to change signs in their derivative. Derivative of cotangent is the opposite, or derivative of cotangent is the opposite, derivative of cosecant is the opposite, derivative of cosine is the opposite when you take those derivatives. So there's our background stuff. Let's do a couple derivatives here. So find the derivative of this thing. I'm actually going to have some fun with this one because we could do quotient rule here, but I'm going to change it just for kicks. So this is really the same thing as 1 over the sine of x minus cosine of x over the sine of x. Well, if that's the case, then let's see, 1 over sine x is the same thing as cosecant of x, and cosine x over sine of x is the same thing as cotangent of x. Well, now when we go to take the derivative, my f prime of x, derivative of cosecant, let's see, go up to your list, derivative of cosecant. Well, it's a cos, so it's going to change signs. Derivative of cosecant has itself in there, and it always goes with cotangent minus cotangent of x, derivative of cotangent. Well, it's a co, so I'm going to have to change the sign that it has. Derivative of cotangent, cotangents always go with cosecants, and the cotangent one's got the square on it. So clean all this up. So negative, let's make this look like it's supposed to. So negative cosecant x, cotangent of x, plus cosecant of x all being squared. So there's one way to do it. Now, if you had done that, Mr. Perkins, what if I had done that with quotient rule? Well, you would have ended up with a problem that had quotient rule in it, or would have had sines and cosines in your solution. Please understand that when you get done with trig, the reason that we spent all that time with identities and being able to change things is I've got an answer with sines and cosines. I look up a solution. The solution or the multiple choice problem has cosecants and cotangents. Are they equivalent? And you need to be able to make that recognition and work your way from one to the other. Second one, a real common way that you get presented problems like this. This isn't going to have much to do with trig, but it's got more to do with that quotient rule that we played around with in the last video. So what I have here is I've got this function, this f of x, being defined as a g of x over an h of x. So I got a single term here that I'm going to take the derivative of. That means I'm going to need a quotient rule. So there's a g of x, there's an h of x. So when I go to take my derivative, I'm going to do a quotient rule. So my f prime of x, I know I'm going to have a big fraction. I know I'm subtracting. I know I got a quantity being squared. So let's fill some stuff in. So low, whoops, I don't want a prime on that one. Low d high less high d low. Again, I got them in the right order because order matters with this thing. Square the bottom, and away we go. Well, what are we going to do with this now? Well, now we're supposed to find f prime of 2. Well, if I'm supposed to find f prime of 2, everywhere I see an x, I'm going to replace it with a 2. So if I go and do that then, let's see. So I'm going to need an h of, so everywhere we see these x's, we're going to start plugging in a 2. So I'm going to have an h of my 2, and I'm going to have a g prime of my 2, minus a g of my 2. And I guess I could stop playing around with colors here, but the idea would be everywhere we get these values, we're going to fill in around them, and we're subtracting here, and we're squaring here, and now we start filling in some 2s. So here's a 2, and here's a 2, and here's a 2, and here's a 2, and here's a 2. So now where do I get that information from? Well, a lot of times in an AP style, they like to give you a chart, much like this one up here. So now everywhere we see your values, start filling them in. So h of 2 is given to be a 3. So what we really have here is we have 3 being multiplied by g prime of 2, which is a 2, minus g of 2, which is a 4, being multiplied by h prime of 2, which is another 4, all over the top h of 2, which is 3, and we're supposed to square that. Clean all this up. How about 6 minus 16 on the top, so negative 10 over the top of a 9. That would be your f prime of 2.